There's a robot called MH3 being built right now in a small factory in Cambridge, Canada, to do the work that kills people every year. It has already been sent, remotely, inside a water treatment plant that no human being wanted to enter. And the company behind it, Mirsee Robotics, just announced something that changes the global humanoid robot race. Mass production starting in 2027. Except the reason this works isn't what you're imagining. It's not legs, it's not artificial intelligence alone. It's an engineering decision that almost no one else had the courage to make, and I'm going to show you exactly what it was. Want to understand it all? Then watch the video to the end and I'll explain it. But first, subscribe to the channel. That way, you'll stay informed about the latest robotics news. A Canadian company called Mirsee Robotics, based in the small city of Cambridge, is about to put the third generation of its humanoid robot into mass production. Its name is MH3. According to the company, the MH3 already exists in 8 prototype units, all currently in the testing and validation phase. Once that stage is finished, Mirsee plans to scale production to thousands of units over the next 3 years, starting in 2027. The target? Factories and industries facing 2 problems at once: labor shortages and work environments too dangerous for human beings. This isn't a figure of speech. The company's stated proposal is to have the MH3 take on tasks that, in Mirsee's own words, are unsafe, repetitive, or physically exhausting for human workers. If you work in industrial maintenance, heavy logistics, water treatment, or any sector where exposure to chemicals, extreme heat, or confined spaces is part of daily life, this directly changes your professional reality in the coming years. In 2017, engineers Tariq Rahim and Robert Ings began developing humanoid robotics at a time when the sector was seen as unpromising and no one believed artificial intelligence would reach a sophisticated level of reasoning. The idea was born from a personal reason, since both of their mothers were facing health problems and the pair imagined humanoid avatars that would give caregivers instant remote access to patients. But the difficulties in that specific market led them to change course, while keeping the goal of creating robots that would spare people from dangerous or exhausting tasks. With the arrival of language models like ChatGPT, Mirsee's current executive director realized that combining that intelligence with a humanoid body would allow robots to perform practically any task. That's the backdrop that explains why a small company in a country that doesn't usually make robotics headlines is betting so big right now. And the numbers behind the MH3 show that this bet is serious. The robot can lift up to 30 kilograms or 66 pounds with each arm. It operates continuously for up to 10 hours on a single battery charge. And it has 31 degrees of freedom, a technical term that, simply put, means the number of independent directions and joints the robot can move, something comparable to the number of joints we use when bending an elbow, rotating a wrist, or closing our fingers at the same time. The more degrees of freedom, the more closely the robot can replicate natural human movements. But the most surprising detail, the one that truly sets the MH3 apart from much of the competition, is the distance at which it can be operated remotely. For specialized tasks, the MH3 can be controlled from up to 1,500 kilometers away, using a virtual reality headset and motion tracking gloves. In other words, a specialized technician sitting in an office can, theoretically, operate a robot doing maintenance at a remote station in the interior of Canada, without ever being exposed to the physical risk of that environment. And this isn't just a marketing promise. According to Mirsee itself, this teleoperation capability has already been tested in a pilot project, a water treatment plant in a Canadian Indigenous community, a remote environment that's difficult to access. Exactly the kind of scenario where sending a professional in person is expensive, slow, and involves risk. This clash between approaches isn't theoretical. It's already happening right in Mirsee's own backyard. While the Canadian company was testing its prototypes in Cambridge, automaker Toyota announced it would bring bipedal humanoid robots, the Digit, made by American company Agility Robotics, to its factory in Woodstock, also in Ontario. Why did a company competing directly with billion-dollar giants decide to give up the market's flashiest design? And could it be that this conservative bet is actually the smartest move in the entire industry? Because what Mirsee's engineers discovered by making this decision explains much more about the future of industrial robotics than any video of a robot doing a somersault. Let's start with the company's most controversial decision. The MH3 has no legs. It moves on wheels. In an industry where almost everyone, from Boston Dynamics to Tesla, is chasing bipedal robots that walk like humans, Mirsee chose the opposite path. Bipedal robots are visually impressive, but each leg adds mechanical complexity, instability, and energy consumption without necessarily delivering real gains in performance or safety for industrial tasks. That's exactly what Tariq Rahim, the company's executive director, summed up in an interview. Except simple wheels also have obvious limitations. An ordinary shopping cart can only go forward, backward, and turn by curving. It can't move sideways without turning first. And this is where the second central piece of the MH3's engineering comes in, the so-called Advanced Mobile Platform. Developed in-house by Mirsee itself, the Advanced Mobile Platform uses a specific type of wheel called a Mecanum wheel. If you've ever seen a warehouse cart sliding sideways, diagonally, without turning its body, you've probably seen this type of wheel in action. Technically, this is called holonomic movement, the ability to move in any direction without needing to change the body's orientation first. In practice, this means the MH3 can squeeze through narrow factory corridors, get around obstacles, and position itself precisely in front of a machine, without the back and forth maneuvering an ordinary vehicle would need. But okay, what if that mobility isn't enough for the environment? The company thought of that too. There are alternative differential drive configurations available for rougher outdoor terrain, which shows that the platform was designed to adapt to the context, not the other way around. Now, let's talk about the part that really sets the MH3 apart from an ordinary industrial robotic arm, how the robot sees and reacts to the environment around it. This technology is called the Hadron Vision System, an onboard stereo vision system developed with NVIDIA Jetson processors and stereo cameras designed by the company itself. Think about how you perceive depth. You have two eyes, each capturing a slightly different image of the same scene, and your brain combines those two images to calculate the distance of objects around you. That's basically how stereo vision works in a robot. Two cameras, two slightly different angles, and a processor that cross-references those images to build a three-dimensional map of the environment in real time. It's this technology that allows the MH3, for example, to locate an object on a table and calculate exactly the distance and angle needed to pick it up. The piece that connects all of this, how a human being, kilometers away, can control that robotic body as if it were their own. Mirsee's teleoperation system works in a way similar to an extremely elaborate ventriloquist's dummy. The operator wears a virtual reality headset, which receives a live 3D video feed straight from the robot's cameras. At the same time, they use gloves equipped with motion tracking sensors. Every gesture of the operator's hand, every wrist rotation, is captured by these gloves and replicated by the robot almost instantly. And the reason all of this works smoothly, without the annoying delay that any bad video call has, lies in an ultra-low latency video transmission architecture developed in-house by the company. The practical result of all this is simple to understand. A specialized technician, with years of experience solving complex industrial maintenance problems, no longer needs to be physically present in a dangerous environment to apply that knowledge. They stay safe, far from the risk, and the body that's at risk is made of metal and circuits, not flesh and bone. The robot's mobile base, that structure on Mecanum wheels we saw earlier, can support loads of more than 300 kilograms. In other words, the robot doesn't just manipulate objects with precision using its arms, it can also be used as a kind of extremely resilient pack mule, transporting heavy materials across the factory floor. In terms of battery life, the MH3 operates continuously for up to 10 hours on a single charge and features wireless charging, which eliminates the need to manually swap cables or plugs, a small detail, but one that makes a real difference during a full shift of operation. Compared to the company's own first generation, the MH1, launched in 2021 with just 6 hours of battery life and no wireless charging capability, the leap is clear. Nearly double the operating time, with far more logistical convenience. In terms of sensory perception, I've already explained how the Hadron stereo vision system works, but where are its limits? Mirsee has not publicly disclosed data on performance in fully dark environments, nor on the robot's maximum travel speed, which suggests these aren't yet the technology's strong points at this stage of development. And here's an important limitation the company itself acknowledges. The MH3 still operates mostly through teleoperation, with a human being in control. Full autonomy, the kind where the robot makes decisions on its own and carries out repetitive tasks without any human intervention, is still a stated goal for the future, not a current reality. In Rahim's own words, the ultimate goal is to add autonomy, so these robots can start doing on their own the physically demanding and repetitive jobs that people really shouldn't be doing. Back to the factory floor. Where exactly has this technology already been tested in the real world? Mirsee carried out a teleoperation pilot project at a water treatment plant in a First Nations community in Canada. A remote environment that's hard to access. Exactly the kind of scenario where sending a technician in person costs time and money, and sometimes isn't even possible. What becomes clear, putting these pieces together, is that the MH3 still isn't an autonomous robot capable of replacing a worker on its own in a factory full of unpredictable situations. Today, it's a physical extension of a specialized human operator, placed in environments where that operator shouldn't or couldn't be physically present. The MH3 has already been sent inside a water treatment plant that no human being wanted to visit, and the technology behind it is already being used through an academic partnership inside hospital MRI rooms. That's engineering working quietly. in places where no one is filming to go viral. Tariq Rahim is betting that this transformation will be bigger than the automotive revolution of the early 20th century. Whether or not he ends up winning this particular race, the standard he's helping to establish, that of robots built to actually work, rather than just to impress in a demonstration, may end up being the model the entire industry copies in just a few years. And that leaves us with a question that's much more personal than it seems at first glance. If your job involved a real physical risk, say, maintenance at a power plant or a contaminated water treatment station, would you rather keep doing that work in person, taking the direct physical risk yourself? Or would you trust your job to a robot remotely operated by you, through a virtual reality headset and a pair of gloves, knowing that what breaks if something goes wrong is the machine and not your body? Leave your answer in the comments. If you liked the video, leave a like and subscribe to the channel. That way, you'll always get notified of new videos. Until next time.